Supervised so it's unsupervised machine learning algorithm. Do you remember anything about unsupervised machine learning algorithm? What is the difference between the supervised and unsupervised machine learning algorithm, Ganesh? Hmm?
Hello?
What is the
Yeah.
difference between
Yeah.
what is the difference between supervised and unsupervised machine learning?
Yeah, I mean the supervised learning, we have the dependent and independent variables, and
Okay.
we do kind of prediction, of the dependent variables, right?
Yeah.
But in the unsupervised, like you have a whole data and like this, we should recognize the trend clustering and all. So with the data, like we don't have any variables and those things. So it's like classification, right? That's what I think.
See, supervised is the part of, so it's a combination of the regression and classification.
Mm-hmm.
Unsupervised is not, it's a clustering based thing. Like,
Yeah, yeah. Mm-hmm.
so in case of, whiteboard.
But the supervisor, the
No
supervisor
label
we
data.
relied on the label input and output data, right?
Hmm.
Right, sir? Hello?
Sorry,
No label data.
no label data. Okay.
Only rely data, right?
Just wait 1 second. I'm there.
Oh, okay, no problem.
Okay. Okay. So, so from the machine learning algorithms, we have a two different algorithms are there. The first one is the supervised machine learning algorithm. Okay. And second type of algorithm is it's unsupervised machine learning algorithm. Unsupervised machine learning algorithm. Okay. The difference between the supervised and unsupervised machine learning algorithm, here we have the label data. Okay, so in case of supervised machine learning algorithm, you have the label data. Label data means which is having the what it can do, what it can predict. It will have what it can predict. Okay, so that we can simply say that it might having the dependent variable. Okay, so dependent variable, when we have the dependent variable, whether it is the classification or else whether it is the regression, it's just different task again, but you have the dependent variable. Okay, when we have the dependent variable, then that situation, okay, it could be a supervised machine learning algorithm. Okay, coming to the unsupervised machine learning algorithm, okay, which means that no label data. Label data means label data means Okay, it doesn't have any kind of dependent variable, no dependent variable. Okay, so without dependent variable, what it can do actually, what it can do, that we will discuss. I will tell you, not worry about that particular thing. So here my question is, if it is the supervised machine learning algorithm, what are the two different algorithms we have it? Under the supervised machine learning algorithms, we have the regression supervised machine learning algorithm, or else some classification machine learning algorithms. Okay, so these are the two different type of supervised machine learning algorithms, right? Coming to the regression based machine learning algorithm, here we have the, okay, the output variable or the dependent variable or the date label variable or the response variable. Okay, so it could be a continuous number data. Okay, when the dependent variable, which is the number type data, then we would like to go for apply the regression based algorithms. You already know that simple linear regression, multiple linear regression, right? And random forest regression, and no ridge regression, lasso regression. We've seen lot many regression based algorithms. Okay, and meanwhile, coming to the classification machine learning algorithms, it could be category or else categorical data, categorical variable. Categorical date variable means it could be string type. The data, it could be like a string format, like yes or no, or true or false, or 0 or 1. So like, nominal and ordinal data type things, then it could be a classification. Okay, even classification also, we've seen that logistic regression, support vector mission, KNN, random forest, XGBoost, different type of classification algorithms. We've seen it. Okay, and even we've seen different kind of projects as well. Okay, now this session, it's purely dedicated for its unsupervised machine learning algorithms. Coming to this particular unsupervised machine learning algorithms, coming to this particular unsupervised machine learning algorithms, you already know that it doesn't have any kind of label data. Okay, it doesn't have any kind of dependent variable. Then how and we will do that, and what we will do that actually. Okay, let me take some example. I want to do some kind of survey. I want to do some kind of survey. The survey, there is no meaning of survey. I just collect some kind of data. Okay, it's survey, but I'm not doing any kind of specific survey. Okay, just data collection. Okay, on from one city. Okay, so the data you're collecting the data. The data, it was like, gender. Okay, you're collecting the data of the gender, age. Okay, and the location they're interested. Okay, locations they're interested to travel. Okay, interested location for traveling. Okay, and how many kids, I mean, whether he is the marital status. Okay, what it could be the status of his marital life, whether it is a single, or whether he is um, married person or not, that kind of information. You're just collecting the data. Okay, so after you collecting the data, okay, after you collecting the data, now I can do, here I don't have any kind of specific dependent variable. I have a gender, age, location, status of that particular person. I have this kind of information. Now I want to give some kind of insight of the data. Okay, now I want to be a cluster. I want to be categorize these people, and what basis, see, maybe some of the people, they're interested for, okay, cloudy, I mean, cool locations. They're interested to travel the cool locations. Okay, and some of the people, they're interested for, hot. Okay, I mean, some kind of location, something like waterfalls and cool different kind of things, like so they're interested different areas, right? So based on this information, okay, you're categorizing this group of people interested for traveling for cool locations. This type of people, they're interested for um, waterfall locations, like they are going to be categorizing it. So you don't have any kind of specific dependent variable, but after you have a data, whatever the data you have it, based upon that one, you're going to be categorizing the different groups. Okay, some portion of groups are interested, these are the people are one specific features they have it there. These are the group of people having the similar properties. Okay, we are making the group of people as same features, same characteristics. Okay, so based upon this 4 or 5 features or 6 or 700 features, so you're going to be categorizing this group of people having this kind of similar properties, this group of people having the similar properties. That kind of categorization we can do with help of the unsupervised machine learning algorithms. Is it clear my point, everyone? Is it clear or not?
Yes.
Okay. So from this particular type of algorithms, we have different kind of algorithms are there. So those things we are calling it, say, clustering algorithms, or else PCA, principal component analysis. Okay. So different kind of algorithms we have it, like clustering, PCA, DB scan, like we have it. So from the clustering based algorithms, we would like to go for understanding the k-means clustering, hierarchical clustering. Okay, so different other type of clusterings we have it. The most important type of clustering algorithm is, it's a clustering based algorithms. Okay, let's go for understanding the k-means clustering. So this is the table of content which is talking about the, okay, what exactly the k-means clustering and what applications of the clustering things, and k-means clustering intuition, and choosing the value of the k, like how many groups, how many clusters you can make with data. Okay, that also we will do with help of the elbow method. And then we have to go for importing the libraries and importing the data set and doing some kind of exploratory data analysis, and declare the features vector and target variables, and convert the categorical variables into the integers, and apply the feature scaling, and k-means clustering model with 2 clusters, or else a k-means model parameter study, and check the validity quality of the weak classification by the model, and use the elbow method to find the optimal model number of clusters, and k-means model with the different clusters, and we will inside of the results and conclusions. That's what the context we would like to go for understand this particular session. Okay, so my first thing is, let's go for in understanding the introduction to k-means clustering. So here it's a machine learning algorithm can be broadly classified into 2 categories, right? So the first one is the supervised, and second one is the unsupervised. There are other categories like semi-supervised learning, which is like a reinforcement learning that we are not discussing at this moment. But most of the algorithms are classified as the supervised and unsupervised only. Okay, the difference between them happens because of the presence of the target variable. Okay, in case of unsupervised machine learning algorithm, we don't have any kind of target variable. Okay, the data set only have input variables which is describing this data. This is called unsupervised machine learning algorithm. When we don't have the target variable means a dependent variable only. When we don't have the dependent variable, when we have only the data set which consisting only input variables, then we would like to do some kind of analysis, or we have to do some kind of creating some kind of models. For that one, we would like to go for using the unsupervised machine learning algorithms. I hope this paragraph you guys are understood. Okay, as of now, that's what only I explain it. Now, from that one, the example of the unsupervised machine learning algorithm is, it's a k-means clustering. Okay, this is the most popular unsupervised learning algorithm. which is used when we have unlabeled means no label data, which is data without defining categorical categories or groups. So you don't have any kind of label variables. That particular situation, this k-means clustering will help you a lot. So these algorithms follows an easy and simple way to classify a given data set through certain number of clusters. So cluster means it's a group means it's a cluster. So we have to create some kind of certain number of clusters and fixed priority, and this k-means algorithms work iteratively to assigning the each data point to one of the k group based on the features that are provided. The data points are clustered based on the feature similarities. Okay, so for example, if I mention the k value as the 3, then this is before k-means clustering. This is the data, the left side photo or the left side image, which is showing that we have some data. We don't have any kind of classification categories at this particular moment. Before k-means the data is something like, everything could be a same data only. Okay, now after you do some kind of k-means clustering, then this entire data we are converting into the 3 groups, okay, based on the similarities. So this is the one group, and this one is the one group, and this one is the one group. Okay, so this is the way you can able to categorize the 3 groups. This is one group, and this one is one group, and this one is one group. So how we are saying that why this is not belongs to this group? Maybe you have a little bit of distance, and moreover this all are the one location, and that means whatever the feature we have it, maybe the same features having the this particular variable as well. Okay, and this sample also having the same features only. So similar features, similar characteristics are belongs to one particular group. Okay, that we are calling it a cluster. Any questions, guys, as of now? As of now, any questions?
No, no answer.
No, sir.
Okay. Okay, so what kind of applications we can do with the help of this type of classification algorithms? So image segmentation, customer segmentation, okay, speciation clustering, anomaly detection, and clustering languages. So you have text. I just given some kind of text. So you have to go for categorizing the this text is belongs to this language, and so this text is belongs to a specific language. Actually, that kind of categories we can do with the help of the okay clustering based algorithms. Okay, like how this particular clustering algorithm can work, let's try to be go for understand here. The k-means clustering used to finding the intrinsic group within the unlabeled data set and draw the inference from them. Okay, it is based on the centroid based clustering. Centroid based clustering in the sense we should make it some point as a center, and around that particular center, if having any kind of similar properties we have it which belongs to the same group actually. Okay, that's what we would like to go for understand what exactly the centroid. A centroid is a data point at the center of the cluster. So what we can do, we have some group, right? From the group, the middle point, the middle data point, we are calling it say centroid. Okay, in centroid based clustering, clusters are represented by the centroid. Okay, clusters are represented by the centroid. It is an iterative algorithms in which the notation of similarity, it is derived by how close data points to the centroid. So whatever the centroid point you declared, so whatever the feature which is near to that particular centroid, that all are one particular group only. Okay, so the k-means clustering works as follows. The k-means clustering algorithms uses an iterative procedure to deliver a final result. The algorithm requires the number of clusters, that means k. So number of clusters we can representing with a k, and the data set as input. Whatever the data input we have it from that one, how many data, how many clusters it might be belongs it, that you have to be specify. If you specify, then it can be making the that many groups. The data set is a collection of features from each data point. The algorithm starts with the initial estimates of the k centroids. The algorithm then iterates the between two steps actually. Okay, the first one is the data assignment step. So each centroid defines the one of the cluster. In this step, each data point assigned to the nearest centroid in which is based on the squared Euclidean distance. So you have to go for finding the distance between the centroid and new point, which one is the very close to that particular point, a centroid, then which belongs to that particular cluster only. Okay, if centroid collection of centroids in a C, then each data point is assigned to the a cluster based on the minimum Euclidean distance, the minimum distance between the the centroid and new point. That so the new point which belongs to the minimum distance Euclidean cluster. Okay, yes, the second one is the we have to go for updating the centroid. So every time initially you are initiating the some center points, but after few iterations we have to update the center. If you're not updating the center, so you cannot get the a pure cluster actually. That's the reason initially you can estimate the centroids, but in future we have to update the center. That is the flow we should understand over here. Okay, in this step, the centroids are recomputed and updated. This is done by the taking the mean of all data points assigned to the centroid cluster. Okay, the algorithms then iterating the between the step one and step two. That means data assignment and centroid. Only this two steps only. The entire process it was iterating between the step one and step two until the criteria is met. Stopping the criteria means no data points are changing the clusters. And if you're not able to change, if you're unable to updating the clusters, centroids, then until unless you have to keep on do this particular process. The sum of the distances is minimized or some maximize the number of iterations are reached, then you have to stop this particular process. This is algorithm is guaranteed to coverage the result or converge the result. The result may be local optimum, meaning that assessing the more than one run of the algorithm with the randomized starting centroids may give a better outcome actually. So initially we should able to go for giving the and so random centroids, but in further things we have to updating the centers based on the mean points. Okay, so that we are calling it say k means clustering algorithms. Clear? So how we can choose the k value, that is the second point. So and how we can able to choose the k point, right? So the k means algorithm depending on the finding the number of clusters and data label for predefined value of the k. To find the number of clusters in the data, we need to run the k means algorithms for different values of the k and compare the results. So you should able to go for okay what we call trial and error method. Okay, you have to take the different values of the k and compare the those results, and which is the thing which is giving the better performance, that particular k value you should take it the optimal value. Okay, that we are calling it say elbow method. So we should choose the optimal value of the k that gives the best performance. There are different techniques are available to finding the optimal value of the k. The most common technique is its elbow method. So how the elbow method is working, let's understood now. This elbow method is used to determining the elbow method is used to determining the optimal number of clusters in k-means clustering. The elbow method plots the values of the cost function. Just we need to go for plotting the cost function. Okay, when we are plotting the cost function, if you're not able to bend, if you're not able to if not decreasing your line, then that point we are calling it say k value. Okay, let's see. I think so. um, I just show you elbow method. Yeah, you can see this graph. So you're taking the different kind of k values. So initially I'm taking the 2 and then 3, 4 and 5, 6 and 7, 8 and 10, right? So by this time, so this elbow shape, right? This is the arm, one arm, and this is the second bend, right? So this is the point, or this is the point we can take it as the cluster as the 2, or else we can take the cluster as the 3 also. Okay, either 2 or 3. So you can see by above graph we can see that there is a nick at k is 2. In k is 2, consider the good number of clusters in the data. Okay, cluster this data, but we have seen that I have achieved the weak classification accuracy 1% with the k equal to 2. I will write the required code with k equal to 2 again, the convenience, and if you see that the accuracy, it could be 0.01. Okay, the result is 63 out of 70 samples are correctly labeled. So our weak unsupervised classification, we achieved very weak classification accuracy. So it's a 1% only. That means that is not a good cluster. So that I just choose the k value is the 3. If I took the k value is the 2, is the 3, you're getting this value, right? Your increases. Like you just go for the updating the k value, and here we are getting the 62%. See, if you're taking the k value is the 2, your accuracy is increased or not? Okay, so in this project I have implemented the most popular unsupervised clustering is the k-means clustering. I have applied elbow method, find the k value is the 2, and k is the number of clusters, can be considered the good number of cluster in the cluster data, and I find the model is a very high accuracy inertia 237, so that it is not a good model to fit the data. I have achieved the weak classification accuracy for 1% k equal to 2, our unsupervised machine learning algorithm. But so I have changed the value k equal to k and find the relative higher classification accuracy. It's a 62% with the k value equal to 2. So that I'm concluding that our k value is belongs to the number of clusters in this particular data set are 4. See, even the elbow method also is saying the same thing, right? See, if you're taking the k value is 2, so this is the one bend, right? And so after the 4, the line which is, it is not converged, it is smoothness. We have a line, straight line we are getting, okay? Parallel line we are getting with the x-axis. But when it is a 4, either you can take the k value is the 4, or else we can consider the k value is the 5 also, okay? So based on the elbow method only, so the optimal k values we can consider it. Clear? Clear or not? Guys, any questions? So regarding about this all steps, this feature engineering and converting normal variables, categorical variables to numbers, this everything we already understood. Okay, this is the data exploration. This data exploration concepts you guys already know it. So you can go to this particular link and you will get it. Okay, first we need to go for importing the libraries and importing the data set and doing some kind of exploratory data analysis. Okay, and if you have any kind of object type, we have to converting into the numerical thing, and if you have any kind of missing data, we have to update those particular missing data, or else here 7050, so total you have the 70550 columns records we have it. Out of that, one column 1, column 2, column 3, column 4, I mean that means there is no use of these 4 columns. Okay, simply you can able to remove it, and finally we are giving one more time summary of this one. And from this one, everything it could be like numerical data except the status id, status type, and status published, so that we would like to go for handle that particular a label data as well. And so what I can do, and here you have to be handle that specific type. Here we have the video, photo, line, link. There is a 4 categories we have it, like we have to handle this kind of number data, categorical data to the number data. Okay, and unwanted data we can able to remove it. So this is what data exploration. And I'm taking the, other than the status type, everything I'm considering the X. Okay. Oh, status type is the label encoder, and Y is the transformation. Here we have the X, this is your X data, and this is your feature scaling and k-means clustering, and this is the feature scaling. That means all data, it could be a same frame. Okay, so this is my entire data. Okay, so this X data you would like to see, you don't have any X and Y, you have only X data. We have it. So you just need to importing the k-means cluster from the scikit-learn, and initially I'm considering the k value is the 2, and if I do this one here, I have the algorithm is auto, and it's a k-means clustering, and its accuracy, it was, so k-means model parameters, and these are the centroids we have it. These many centers we have it. These are the centers. It's a k-means cluster centers actually. Okay, so it's inertia, it could be very high. If the inertia is very high, we can't considering the good result actually. Okay, so that it's a k-means inertia, it's 237. So if it is a very high, the lesser the model inertia, the better the model actually. So here the inertia will be very high, so that this is not a good model. Okay, even accuracy also, it's a very less. So that we would like to go for check the quality of the weak classification web model with help of the accuracy, and the accuracy, it's around 0.63 63 samples are the correctly classified, okay, or categorized. So accuracy is also very less, it's 1%. So that's, I choose the elbow method. So for elbow method, we need to be, you need to do that, cost function. We are taking the multiple k values. Initially I'm taking the k value is the 1 till to 1 to 10. So for different k values, I'm storing the each and every result cost function, cs in the sense cost value. Okay, so our inertia value. So we are applying the, I value for I value in the sense initially 1, next time it's a 2, next time 3, 4, 5, 6, 10, like this. This, the for loop can be repeated 10 times. For each time we are getting the inertia, right? The inertia we are loading into this particular cs. That means this is one list. I can plot this particular cs. I just collecting the inertia values from the k-means clustering for different k values, and from that one, so where the class, where the your model could be reached the local minimal point, that particular thing we are calling it, say, number of clusters. So here 4, it could be, I'm considering the, okay, local optimal number. So even for different k values also, we are getting the bad results. With help of the elbow method, I'm finally concluding that my model is a good. Clear? Any questions, right? How the k-means algorithm is working? Based upon the elbow method. Elbow method means what? We are taking the different k values and finding the cost values for each and every k value. And after you plot that particular thing, then which is the thing will be giving the less inertia, that we are calling it, say, number of clusters. Clear?
Hi, not clear. I'm still not sure why we choose 4 from the others, because I
So
don't see how it's different from the other like points in the graph.
see, this is the graph indicating that inertia. Okay, if the higher the inertia, okay, it's not a good model. So when I'm considering the value of the 2 number of clusters, I'm considering the inertia around more than 200. Okay, and if I'm considering the 3, then it's between here. Okay, if I'm considering the 2 or 4, then it could be here. Okay, but when it comes to the 5, even 5 also could be the same, approximately same, right? Even 6 is also almost similar, right? Okay, so even we can take it, either 4 or 6, it's up to you. But usually, so which is the first number, which is the less number is giving the best inertia, okay, or optimal inertia, that particular number we are considering the optimal or k value, optimal k value. okay, or optimal number of clusters. Clear?
Clear. So we could easily choose 5 or 6 if he
Yes, of
if we
course.
decide.
We can.
Okay.
It's of course. It's up to you. No one can object to you why you are taking 5. Okay.
Okay. Okay.
It's all about
Uh,
you should have a better, okay, better inertia. Okay, so very less inertia, which is giving the high best model actually. So even you can take the 10, but you know the difference between the 10 and 8. Any difference is there? No, right?
Not that much. I think 5 is very the
Yes,
best for
5 is optimal. 5 is optimal.
yeah.
See, it's up to you actually. Okay. Yeah. So that's a way you can do it. This particular k-means clustering algorithm. I would like to be share this particular document all of you in the canvas, and that's for today's session, guys. And guys, please come for Python sessions as well. Okay, today onwards we have a Python session.
Okay, thank you. And but do we have any class tomorrow morning in the morning?
Yep, tomorrow morning we have a Tableau session.
Okay.
I would like to tell you the time. Okay.
Okay. Which is gonna be bring oh sorry.
It is starting on the Tableau method.
Yes, yes. You can come.
Okay.
Okay. Bye, guys. See you. Take care.
Thank you.
Okay, thank you. Bye.